going to show you how to solve a system of linear inequalities by graphing. As a review, to get us started for this, I'm going to remind you of how to graph just one linear inequality on a coordinate plane. So this is something we did back a couple units ago when we were talking about inequalities. We're going to take this inequality, y is greater than negative 1/2 x plus 4, and we're going to graph it on this coordinate plane. So, first of all, my y-intercept is 4. So I'm going to start at positive 4 on the y-axis. My slope is negative 1/2, which means I'm going to go down 1 and over 2, down 1 and over 2, out of room there, or I could go up 1 and left 2. Now I'm out of room here as well. Now, before I connect that, I'm going to look at my inequality sign. My inequality sign is greater than. It's not greater than or equal to, just greater than. Which means when I connect these dots, I do not want to include the actual line itself. I want to include only things greater than the line, which means I'm going to use a dotted line to connect. Now, some of you on your test on inequalities would finish there and be done, but we're not done. We have only showed the border line. This is the line that we want all values greater than. So if I want all values greater than, that means I want all values that are above the line. Conversely, I could also use a test point to see where I want to shade, which side of the line needs to be shaded. For example, I could use 0, 0 as my test point. What I would do then is I would plug in 0 for y and 0 for x and see if I come out with a true statement or not. If I do this, negative 1/2 times 0 is 0, plus 4 is 4. So that would say 0 is greater than 4, which is not true. So 0, 0 is not one of my solutions, which means I want to shade the other side of the line, or as we said before, above the line, which would be this portion of the graph. Hopefully that rings a bell for you and you're remembering how to do that too. So what we're going to do now, again, is solve a system of inequalities. A system of inequalities is just more than one linear inequality with the same variables, just like we've seen systems of equations. In order to graph a system of inequalities, let's try to get this out of the way here. There we go. First thing you're going to want to do is put both inequalities into slope-intercept form. Delay. I'm trying to get my next. Here. Then you're going to want to graph each inequality on a coordinate plane. So you want to get your inequalities into slope-intercept form, which they may already be in. Then you want to graph each inequality on the coordinate plane. Remember, when you do that, you need to shade either above or below the line to show where the solutions are. Then, here's where it's different. We're going to have two inequalities. So we're going to have to determine where the solution is. Well, that's going to be where the graphs overlap. So you're looking for where the two shaded areas overlap. If they don't overlap, then there is no solution. So let's take a look at some. Okay, here are my system of inequalities. I'm going to do one in red. So I'm going to do that first. So y is greater than 2x plus 3. So 3 is my y-intercept. My slope is 2, so that's up 2 and over 1. I'm out of room, so I could also go down 2 and left 1. Now I have to think about what kind of line do I need. Since it's just y is greater than 2x plus 3 and not greater than or equal to, I'm going to use a dotted line. And now I have to think about where do I want to shade. Since it's in slope-intercept form, and it's a greater than sign, I could just say I want to shade above the line. But that's a little hard to tell. So I can also choose a test point like 0, 0. If I plug in 0 for y and 0 for x, I end up with 0 is greater than 3. Well, that's not true, which means 0, 0 is not a solution, which means I want to shade this side of the line. Go ahead and pause the video and try the other inequality. Graph the other inequality right on the same coordinate plane. When you're ready to, you can press play and check. All right, I'm going to do this inequality in blue. My y-intercept is -1. The slope is also -1, which means I'm going to go down 1 and over 1, down 1 and over 1, down 1 and over 1. Or I could go up 1 and left 1, up 1 and left 1, up 1 and left 1. This time, because it's less than or equal to, I'm going to use a solid line to connect my points. And now again, I have to decide where to shade. So this time it's in slope-intercept form and it's less than. So I want to shade below the line. Or I could test 0, 0 again. If I put in 0 and 0, I would get 0 is less than or equal to -1. That is not true. So 0, 0 is not a solution, which means I want to shade this side, which is also the side that's below the line. Now you may notice that the two lines we drew do intersect, but not at an exact point. So I have my two lines intersecting, and then I have overlap where the two graphs overlap. So I'm going to darken in that part that's shaded by both. And that green area are where all the solutions to both of these inequalities would be. Any point in this green area is where the solutions are. For example, -3, 0 is a point there. If I plugged in -3, 0, it would work in both this inequality and in this inequality. You can check if you'd like to. But any point that's in the green area will work in both inequalities. If you're working on this at home, you can either use colored pencils to help you do this, or you can use two different colored pens, or whatever is most easy for you. Just make sure, or even if you just use pencil, just make sure that you really darken in the shaded area where they both overlap. All right, let's try another one. This one has one of our special types of equations. Y is greater than 3, or like y equals 3. That's actually a horizontal line at 3. It's every point where the y value is 3. Now it's just greater than, so it's not or equal to, so I want to use a dotted line. And then it's greater than, so I should shade above the line. Or I could test 0, 0. If I plug in 0 for y, it says 0 is greater than 3. That's not true. So 0, 0 is not one of the solutions, so I would shade the opposite side. I'm going to do the other one in green. This one's not in slope-intercept form, so I may first want to start by getting it into slope-intercept form. To do that, I would just have to subtract x on both sides and end up with y is greater than -x plus 4, which means that the y-intercept is 4 and the slope is -1. It's greater than, not greater than, or equal to, so I'm going to use a dotted line. And it's greater than, so I want to shade above the line. Or I could try plugging in a test point like 0, 0. If I plug in 0, 0, I end up with 0 is greater than 4, which is not true. So I do not want to include 0, 0. So I shade the other side of the line, or above the line. Okay, now I'm not done yet because I need to identify where are the solutions, where is the overlap. So I look for where both blue and green are shaded. and that's up here. So this entire section that I'm shading in black is where all of the solutions are. So numbers like 3, 4, or 4, 5, anything in the black area would be a solution to this system. All right, why don't you go ahead and try this one on your own. One of the inequalities, is already in slope-intercept form, the other is not. So put the one in slope-intercept form that's not, graph both of them, and see where your solution area is. When you're ready to, you can play the video and I will show you what I get for my answer. Okay, if you have gotten through to this part, make sure that when you converted this equation into slope-intercept form, you notice that this is a negative y. Because this is a negative y, we have to divide by negative 1 on both sides. When you divide by a negative, you have to remember to flip your sign. So your second inequality should come out to y is greater than x plus 1. When I try to shade, if I plug in 0, 0, I get 0 is greater than 1, which is not true. So I don't want to shade the side where 0, 0 is, so I'm going to shade up here. Now, what is the solution to this system of inequalities? Well, the solutions for the blue inequality are above the blue line. The solutions for the red inequality are below the red line. There is no overlap. That means that this system of inequalities has no solution. So if the shaded areas never overlap, then there will be no solution. What we're also going to be talking about in class is how you could write a system of inequalities from the graph. So if you'd like to give this a try, you certainly may. This is what we'll be talking about in class when we discuss this. Thank you for watching.